Time to jump into the second session. This time we have an interesting topic from an interesting speaker. Yes, our next presenter is David O'Brien. He's going to present on the topic startup infrastructure, how to make scaling its sales, not a tech issue. David is the founder of ARGOS Security. It is a startup that helps the customers by finding, investigating, and fixing cloud vulnerabilities.
That's right. David will be demonstrating how they have leveraged the Azure PaaS services like Azure Functions and especially Cosmos DB to build a SaaS product that scales effortlessly already, and it's already handling millions of requests. He will walk us through how simple it was for him to build the foundations for their product and why they chose Cosmos DB for it and not any other database. Great to have you here, David. Over to you.
Hi, everybody. Welcome to my office slash shoe closet slash baby room. So everybody working from home probably knows what I'm feeling. Great to be here. And let's jump right in. Good. So, startups infrastructure. Today I'm here to tell you a bit about how we build ARGOS, a cloud security product. I'm not going to spend too much time about talking about the product itself. It's not a sales pitch here, but really want to tell you from day zero, from day dot, what decisions did we make to make sure that we, once we hit commercial success, pretty much, or once we hit our ex-customer, that our infrastructure wouldn't hold us back. So we really wanted to make sure that sales could run as fast as possible, as fast as they needed to, and we wouldn't fall into this trap of, oh crap, on Monday, that huge customer is going to sign up. We need to quickly deploy some more virtual machines. So we didn't want that. How did we do that? Quick, who am I? David O'Brien, you've already heard my name. I'm a Microsoft Azure MVP for 8 years now, I think, 8 or 9 years. Been around the cloud ecosystem for quite a while. And 2 years ago, I founded ARGOS Cloud Security. I'm from Australia. I'm based in Geelong, the top right picture. It's a beautiful city of Geelong in Victoria, Australia. And if you've watched the Formula One just recently, it's close to Melbourne. You see the Formula One racetrack down here around Albert Park Lake in Melbourne. I also like to fly planes around Australia. So that's another hobby if you really want to get in touch with me and talk about IT, startup, or aviation. Here's my contact details. Always happy to get in touch with people in the community and help them get started in the cloud, be secure in the cloud. So quickly, why did we build yet another cloud security product? And here's a very, very strong statement, but it always gets people thinking and starts really good conversations. Because I believe that even though the cloud, the public cloud, could almost get a driver's license in most countries nowadays, as an industry, generally speaking, we're still getting cloud security basics wrong. And I don't believe, and I've never believed, that that's actually due to us not being able to detect issues, but mostly due to us not being able, from a time point of view, to actually approach or address any of these issues that were detected. Case in point, over and over and over again for over 13 years now, as a consultant, companies would ask me to come back into their environments and fix things, figure out which of the issues that a certain product found for them were actual security issues, and not just best practice violations in quotes. So that's when we started eventually thinking about how can we help organizations actually fix this issue, help them address their security concerns in the cloud. And we had a few golden rules, we called them, while building this product. and starting the company. Number one, we went all in on Azure. I've never believed that lock-in is a bad thing, especially when starting a startup. You need to be focused. So all in on Azure and PaaS, platform as a service, services, if possible. As a security product, it needed to have a strict focus on security, which really meant to us, again, PaaS, push most of these concerns over to Microsoft, our cloud provider, because arguably speaking, at an infrastructure point of view, at an infrastructure level, they're probably a lot better at securing certain things than we would be. Startup, we were bootstrapped, means we don't have any external investment, really. That means money is tight, so free tier as much as possible, where PaaS also comes in again. Where we had to buy third-party solutions, or where we had to use third-party solutions, we decided that one criteria for a third-party solution would be they need to have a startup tier or need to have a free tier. Buy over build, strong fan, big fan of buy over build. Nobody wants to run their own Exchange server. That's why we're all buying Microsoft 365, Office 365. Yeah, so all of these things, if somebody's already built it, why would I try to build it again? If it's not part of my business, I'm just going to buy it. And automate everything. We had a very, very strong stance on whatever we did, we had to get it automated from day one. And this is our architecture diagram, really. There is no secret sauce necessarily, except for a bit in the code, obviously. But there's no secrets around how we built, how we architected Argos. Overall, what we're going to focus on today is in the middle, our function app. And in the lower left, of course, that's why we're here, our Cosmos DB account and our databases that we use for the backend of our application. So let's dive a bit deeper into that. Just generally, you don't see any virtual machines in here. Everything's PaaS. Our front end at 12 o'clock is a static website on storage accounts. We have not moved that to static web apps yet. I'm not necessarily sure if we will. If you've not looked at static web apps, have a look, different topic. We are using .NET Core for our application, but we run that on Linux because we don't care what operating system we're running on. So we just went with Linux, pretty much flipped a coin, and it landed on Linux because nobody should care what operating system you're running stuff on. Our database, as I mentioned, Cosmos DB, that's where we store our customer information, all the things we detected in customer environments. We encrypt all our sensitive information in these databases. And we use Key Vault to hold our encryption keys to really store sensitive information in the end, like certificates, other secrets. We use application insights, lower right, for logging, telemetry, observability, all of that, these abilities. And then there's third-party stuff in the upper right that we don't have to go into today. But we use this application to now scan our customer environments on all three clouds, actually, on Azure, AWS, and GCP. So to do that, how did we do that? So let's dive a bit deeper into the application itself, the Azure Functions, and specifically then after that, the backend, and why did we use Cosmos DB opposed to a SQL database, because that's easiest in quotes, because you probably find a bazillion blog articles on the internet dating back to the 1990s on how to do a SQL database. So why did we use Cosmos? one, back to PaaS and Functions and Cosmos, this is what we get, for example, looking at application insights. Without actually doing a lot, and just a bit of configuration, using all these services that we are going to dive a bit deeper into, we get this amazing map, application map, a service map out of application insights that will show us where there's issues, what issues are there, how many calls, how many invocations, which one's a bottleneck, why is it a bottleneck. Really, really simple for us to dive into our application without deploying agents, deploying virtual machines, configuring IIS to forward telemetry to other endpoints. None of that required. All we had to do was put a key somewhere, and that was it, bit of configuration. So the infrastructure itself, the application, as I mentioned, we use Azure Functions. We started with the consumption plan, the dynamic consumption plan for Linux. Why? Because it's free. Yeah. On day one, you don't know if you're going to have, and we didn't know as a startup, if we were having commercial success, if we were going to have many customers. So we went with consumption plan. We're now on a premium plan for multiple reasons. But on a consumption plan, yeah, sure, you're going to have cold start issues, maybe, that you can work around. But really, in the beginning, who cares? Your customers know you're an early startup, but who cares? Now we have over 120 functions across 2 app service plans, pretty much split into front and back end. We should probably split that even more, but if we wanted to, that's an easy code change. Again, because we're using this PaaS or FaaS, Functions as a Service platform, to do all of this. We don't have to deploy more virtual machines. All of this happens automatically. And as I mentioned, logging and telemetry all happens via application insights just through configuration. And speaking of the automation, we use Pulumi, infrastructure as code, to deploy all our infrastructure. And to deploy this function app, this is all we had to do. A couple of lines of code, and you can do the same in Bicep or ARM templates, obviously. But we use Pulumi here to configure what we want to see. We use system-assigned identities. Further to the middle, you can see system assigned as a managed identity. So we don't have to configure any passwords. We don't have to hard code any credentials anywhere. This is all taken care of by the platform, by Azure. So that if our function would have to go and get something out of a key vault or have to do something to our Cosmos DB backend, it would just know how to authenticate to that. So really simple for us to deploy this. And also, as a startup, sometimes back in the beginning, we also screwed things up or things fell over and we just redeployed from scratch. And that was easy enough because we started with our infrastructure as code approach, everything automated, and that made it really easy. So why functions? Just a couple of points on why functions. Well, they automatically scale in all dimensions, up, down, in, out, happened automatically. We didn't have to do anything for that, especially on the consumption plan. There were a few constraints, which is why we're now on the premium plan. Mostly that was due to memory before we refactored and split up into multiple app service plans. But really, now that we have quite a lot of customers on this, quite a lot of activity, we're now on the premium plan. But it also means we don't have to patch anything, no infrastructure. Yeah, you call it serverless. Yes, there are servers, but we don't have to worry about them. It's Microsoft's responsibility to patch them. I don't care if our function is running in a container or if it's actually a Linux VM. Don't care. It's probably a container. But that's Microsoft's responsibility to make sure they're patched. If one dies, they come back. Yeah, we don't have to do that. Which means that all that is something which means we can focus on our code. We can focus on the thing that is going to make us money. One of the most important things was the easy, really easy integration with Cosmos DB, with our backend, and other third-party services via native bindings. You can really simply say anything this function does and spits out in the end, just chuck it into our Cosmos DB. There's a connection string configured somewhere, and it just knows whatever it returns gets put into Cosmos DB. So focus on our own business code. We didn't need to have OS experts on the team, which also applies to why Cosmos DB. We didn't need to have a DBA, really, that knew how to deploy a SQL cluster or a SQL always on across multiple availability zones or regions with quorum and all of that. No need for that. We just write our code, what really sets us apart from everybody else in the industry, and we make sure that that's good. We don't need to be good at deploying a virtual machine. Microsoft is good at that. Which also means that day 0 and day N questions were really already answered by the platform. On day 0, scaling was already answered by the platform. We didn't have to do that. Potentially, we just have to put some limits and constraints into the platform so it doesn't scale indefinitely or into infinity and costs us eventually quite a lot of money. But really, we didn't have to figure out how to do things. Functions also have an amazing local development experience, in my opinion. So onboarding of new team members now happens pretty much in under an hour. And the big one was also on the consumption plan, you get a monthly free grant of 1 million requests on your function and 400,000 gigabyte seconds of resource consumption per subscription. That's quite a lot, although we already blew past that by far. But initially, that's important. That's money you don't have to spend. So we had the Cosmos DB conference here. Let's talk about Cosmos DB, our backend. Similarly to the functions argument, why did we use Cosmos DB? Because it does come with a free tier, by the way. You can get one Cosmos DB account in your subscription with 1,000 request unit per second and 25 gigabyte storage for free each month. That can already get you quite far, depending on how you build your application, how your queries run, how well you do your queries. That's going to get important in a second. You can already get quite far with 1,000 request units per second. Don't have to go too deep into request units per second, but it really depends on how you also build your queries. Microsoft charges you based on the compute, basically. They have to set aside for you to run a query and return the results. Well, very quickly, we got stung with $600 on that Cosmos DB backend, which ended up being the most expensive, but also the most valuable aspect of our application, really, before we started optimizing our spend here. We mentioned functions are really easy to use with Cosmos DB, and it's the same here. It was so easy. So much code we didn't have to write. So much time we didn't have to spend figuring things out. No patching required for Cosmos. Yeah, it's all taken care of by Microsoft. Database as a service, Microsoft patches the database, the underlying infrastructure. We don't have to do that. We don't have to figure out how to do the patching. There is no message to customers, excuse me, Argos is going to be down for the next hour because we're patching our database. None of that's required. Same with High availability pretty much comes for free, depending on how you define high availability. Our data is replicated 4 times just in one region. And just a very quick news item, basically. A few days ago, Cosmos DB actually announced that auto-scaling can now happen from 100 to 1,000 request units instead of 400 to 4,000 request units. You can actually save quite a bit of money with that on database containers that aren't very active. To show you how we deploy it and how easy it is for us to really make changes also here. As an example, we only deploy into a single region our database for now, even though we have multiple databases, but for now, for compliance reasons, but for now we only deploy each database account into a single region. If we wanted to deploy it into multiple, because it's PaaS, we just tell the service here in the geolocations list down here towards the end, we add another location, another region, and that's it. We push the code and Microsoft figures out how to do it. We don't have to figure that out. The scaling was really important to us, similar to the aspect around the functions, that this is all taken care of by Microsoft. You probably see the pattern. We pushed to make sure that all of the issues that we might see as a startup, that we don't have to deal with them, we push that to Microsoft. Scaling, patching, all this ops stuff, we push it over to Microsoft because they're really good at it. So scaling on the database happens based on demand. And we can define certain limits on both sides where we want scaling to happen, and Microsoft just figures it out. If we know there's very static, very constant usage on certain containers or database containers, then we can also define that, and we can define that in code as well. Right now, we have roughly around 17 million requests every month. And because we use this PaaS service, Cosmos DB, it's actually, even without us doing anything, you go to Azure Monitor and you get this nice picture here where you can see all these metrics, the data usage, how many requests on each account and database and collection, how many documents you have, which is why I can tell you we have over 3.3 million documents in our databases, which roughly equates to probably 3.28 million cloud resources under management and 17 million requests. This is, we changed the filter to scale, to month. So roughly 17 million requests every month on this database, and we didn't have to change anything from when we had only 100 requests against this database to now 17 million requests. And we're not expecting to have to change really anything for when we have 10 times as much, because Microsoft takes care of that. We just sell the product, make sure customers are secure in their cloud, that they are taken care of. We build a really good product, but scaling is not a tech issue for us. So a couple of tips and tricks before we probably have to wrap up at some point. Free tier was really appealing to us, and it should be to you as well, especially if you're a startup, and startup in this case, by the way, lots of people glaze over when I say startup because they're working at this big bank or big enterprise or whatever. There are startups inside of enterprises, inside of banks. If you're a team, you're building something new, you're a startup, period. Convince me otherwise. We knew that our data will be very random. That's why we used Cosmos DB. We didn't want to spend so much time figuring out what our database schema is going to be to build a SQL database, really, knowing that the data schema is probably going to change in a month, in 2 months, again. And we would have to do the whole exercise again and again and again. So having a non-relational database like Cosmos DB was actually really helpful. We could just chuck the data into our database and just query it back via code. And it didn't care about a schema. Super powerful for us because all the data we get from Microsoft, from Amazon, from Google, all these schema or these resource configurations basically are all very, very different. And we couldn't properly predict them. So having a pretty much chuck it in their database like Cosmos was really powerful. Speaking of querying it back, support for SQL API meant that all our .NET developers were super at home. Just really easy adoption. Really fast read actions was important to us because we query our database a lot. All our scans that we do against our database, because we scan pretty much in real time. We scan continuously our customer environments. We needed to read so many times. And Cosmos is just great for that. However, on the flip side, our queries initially were really bad and expensive. Some of these queries consumed way over 5,000 request units. And initially, we didn't fully understand why. We were constantly seeing 429 throttling errors, where Cosmos DB said, well, you don't have enough request units available. So, and because we also went, oh, maybe we shouldn't scale beyond this number of request units because it would be too expensive, we were constantly hitting these HTTP 429 errors. As it turned out, the C# SDK that could help us build these Cosmos DB queries was really helpful, but it can also hide bad queries, hide in quotes, because without going into, because that could easily waste a week of workshop into query design, really how you query, how you filter can make a massive difference in Cosmos DB. So we luckily send all our Cosmos DB metrics into application insights, log analytics actually, and we could just use this query here that you can see, and that's actually straight from the documentation. So don't worry about copying this, but feel free to take a screenshot. Take this query here and actually see which queries were consuming which or how many request charges. One gotcha though. On the right, the column, you can see request charge _s. It seems like request charge is actually a string, not an integer. So when in the documentation, and I do need to probably report that, in the documentation it says order by this string, it doesn't properly order by the number of the request charges. As you can see, 9 is not greater than 89.89. However, once you know that, once you've seen that, you can do your own sorting and filtering. You can export it to Excel and all of that and do your own thing. But it then tells you, well, this is the query. Maybe you shouldn't be doing it this way. Maybe you should be doing it that way. Or maybe we need to change our C# code to do it properly. Super helpful. Saved us a ton of money to, in the end, use these diagnostic metrics to really give us more insights. It also turned out we over-indexed our documents. we really didn't have to index everything that we almost never or rarely queried on. Azure support was really helpful figuring out these things with us. They actually helped us reduce our costs so much. They saved us a lot of money. So they were worth their time in gold, pretty much, while improving our application's performance. We worked with them, had a few workshops with them via tickets and the startup team, and they made our application better and cheaper, which was just amazing. Highly recommend. And that's how we ended up building an application that can now help our customers find and really automatically investigate security issues on their behalf. No human needs to go and build a diagram like this. This is all done using Cosmos DB and Azure Functions in front of that to really build this real-time diagram and paths. You can see the red graphs, and on the other side, on the right side, how somebody could potentially laterally move through your environment. This is all powered by Cosmos DB and Azure Functions. And with that, I want to say thank you very much for having me. I think I'm up to time. If you're interested in this, have a look on what it means. There's a free, absolutely free, we don't even ask for a credit card, free trial for you to take a look. But hit me up with any questions on Twitter, on email, whatever you want to use, if you have any. And thank you very much for spending the last, I think, 25 minutes with me. Thank you.
Yeah, that was an awesome session with lots of do's and don'ts, right, on architecture and also especially on the Cosmos DB side. We have a few questions from the audience that we want to take them up. You mentioned about using Pulumi, right, for the infrastructure as code. Why didn't you choose some of the other tools such as Terraform or even Azure DevOps?
So we use GitHub Actions to deploy because it's free. We didn't have to pay anything for it. And we don't use Terraform, we use Pulumi because our application our front end is written in in Angular, TypeScript, and we can define our infrastructure also in TypeScript using Pulumi. So our developers, our engineers don't have to learn yet another language. Terraform is a completely different language that only applies to Terraform and nothing else. Pulumi's languages apply to everything else.
Thanks, David.
No worries.
Makes sense. There's another question, David. One of the comments is that the person is heading a bootstrapped startup as well, and he has decided to make usage of Azure Functions with Cosmos DB. But his question is mainly on the Azure Function, using Azure Function in real life scenarios, replacing a web API, especially the problem of cold starts. So did you face any such issue, and how did you get past that?
Yes, we absolutely did in the beginning, which was absolutely expected and accepted because we were on the consumption plan. It's a free plan. You get cold start issues if your application isn't running all the time. We absolutely accepted that. We communicated that to our customers that might happen, that they might have to click a button again for something to happen. They were fine with that because they knew we're a startup. Now we're on the premium plan where we don't have these issues anymore.
All right. I think we have a couple of more questions, so I will merge them together. So you spoke about being vendor locked, and personally, I have seen that startups they usually don't stick one vendor, and it was very good to hear that you have stick with Azure. What are the top 3 things that that made you to stick with Azure? And I'm sure security is one of them. And a couple of questions that to add on, right? And how security is handled in case of Cosmos DB, and how do you handle the sensitive information? And also, have you implemented a caching strategy to lower the cost in terms of the queries that you're making?
Cool. So lock-in, if you're a startup and you're worried about lock-in, you're worried about the wrong thing. yeah, you should be focused on building your product and building your application, not about how can I potentially move it over to a different cloud provider or whatever. You're worrying about the wrong thing. 2, we're not using any caching at this point. Our data also changes way too often for caching to make a lot of sense. Security, we use Defender for Cosmos DB. Woohoo! New service, new feature available in preview. Go enable it on your Cosmos DB accounts. That does protect our Cosmos DB account quite well. We haven't seen any alerts come out of it yet. Fingers crossed, touch wood, all good. And I do have a blog article on that on my blog as well, that explains how to actually enable it, but it only takes 30 seconds. And at the moment, I think it's free.
All right. Thanks, David. I think those are the questions that we had from the audience. And thanks for the awesome presentation. I hear from customers on a daily basis, managing the infrastructure, especially at scale, can be hard. You must follow the best practices, use automation infrastructure as a code to do the things right. Especially when you do startup, and as a startup founder, you must always ready for that unpredictable surge in traffic that you mentioned in your session. I think you have covered most aspects of it. Sweta, what did you get out of this session?
No, what I really appreciate, Saji, is the clarity, David, that you had that, hey, I don't want to build what's already available. I just want to make the best use of all the PaaS services and everything that's available on Azure to build my service quickly. So that clarity of thought is exactly what we build the platform for. So that's awesome, David. Thanks so much for your time again. And I'm sure all other startup founders, as well as anybody who is trying to build a new service or trying to scale it, will benefit from your insights today. So that's really great. Thanks
Awesome.
again.
Thank you.
Thank you, David.